Hello, wonderful person. Aaron speaking.
And in this video, we will be talking about graphing linear equations.
This is the only type of equation that you'll be expected to either graph or get an equation from for this exam. So you aren't expected to know anything else about other equations in terms of what they look like or how to graph them. And luckily, linear equations are the most basic ones. So we're going to focus on how you're going to go about doing that for this exam. So first things first, we need to identify what is a linear equation. If you're looking at a graph, a linear equation is just going to be a straight line. And I drew it like this, but it could be going in the other direction. So now I have two linear equations going opposite directions. But whenever you have a line that's just a straight line, a function that graphs as a straight line, that looks like a linear equation. That's what it looks like graphically. But what if you have a function and you need to identify if that's a linear equation, which is something you are expected to know how to do. Let's look at two different equations. Let's say we have y is equal to 5x plus 2, and then let's say we had y is equal to 5x squared plus 2. One factor of all linear equations is that there are no exponents on either the x or the y. Or you could say that the exponent is 1, meaning that it doesn't change. So one thing that's consistent about all linear equations is that there's no exponents on the x or the y, and that it could be written in this form: y equals mx plus b. Where m and b could be any numbers, what's essential is that, again, there's the y and the x are on opposite sides of the equations, or at least you could write it that way, and that there are no exponents on it. So if you look at these two equations, this one is linear. However, this one, it's not linear. If we were to actually graph that, the graph of that equation will look something like this, which you don't need to know at all. All you need to know is, looking at this equation, because it has this exponent, it's a nonlinear equation. Sometimes you might see an equation like this. Let's say we had 2y minus 4x is equal to 3. Even though this isn't in y equals mx plus b form, it still is a linear equation. And one way you can identify that is, A, there's no exponents on either the x or y, and just to clarify, you could try to solve for y and get it in this form. So what do I mean by that? I'll just show you. So first I'm going to try solving for y. I'm going to start off doing that by adding 4x on both sides plus 4x here. So then that gives you 2y is equal to, now I have positive 4x on this side plus 3. And now I'm going to divide everything by 2. And whatever you do to one side of the equation, you do to the other side. So that gives me 2y divided by 2 is just 2. It's just y. 4 over 2 becomes 2, because 4 divided by 2 is 2. And 3 divided by 2 is 1.5, or I could just leave it like that. So even though it's not in y is equal to mx plus b form, this function right here is still a linear equation. So that's one thing. One type of question they could ask you is identify which of the following is not a linear equation. If it has an exponent and you can't write it in y is equal to mx plus b form, then it's not an equation. So what does this m and what does this b mean? This b is called the y-intercept. And the m is the slope of the linear equation. And those are the only two things you need in order to graph a linear equation. The y-intercept is where it crosses the y-axis, which I'll get into shortly, and the slope is basically how much is it changing. So one way you could look at slope, which might help you when it comes to graphing, it's your rise over run. So a lot of times you might see your slope as a fraction. That's going to help you when it comes to graphing it, because the numerator is going to tell you how much it's rising, and the denominator will tell you how much it's running or moving on the x-axis. So now let's look at a graph and try graphing an equation. So this is called a Cartesian coordinate. You don't need to know that. You just need to know how to work with it. This horizontal line right here is called the x-axis. The vertical line is called the y-axis. The point where they intersect is called the origin, and it's called 0, which is 0, 0. So the x values will be going from left to right. This is x equals 1, x equals 2, x equals 3, x equals 4. Whereas the y values are going up and down. This is y equals 1, y equals 2, y equals 3. And as you can see, these are negative values going down, negative values going to the left. So how do you graph an equation? The first thing, let's say we have this equation, y is equal to negative 2x plus 3. The first thing you want to graph is the y-intercept. They tell you that your b is a y-intercept, and you can see that the b here is 3. So that means you're going to go to the y-axis, go to where 3 is, and then draw a solid dot on that point, because the equation is going to pass through this point. And then bam, that's your y-intercept. Now the next thing you want to look at is the slope. The slope is negative 2. So let me write that over here, slope. And this is going to help us plot the rest of the points. Now I said earlier, it helps to write the slope as a fraction so that we can plot it using rise over run. So negative 2 is the same thing as negative 2 over y. Or I could look at this fraction as 2 over negative y. Both of these gives you negative 2. So how is this going to help us graph it? Keep in mind the numerator is rise and the denominator is run. So let's look at this fraction. Rise negative 2, run y. So you're going to first start off at the y-intercept. And if you're going to rise negative 2, that means you're going to go down 2 units. And for every 2 units you go down, you're going to run positive 1. Because right now I'm rising negative 2, which means go down 2, and I'm running over 1. So the next point on the graph is going to be here. I could do that again from this new point that I just plotted. Rise negative 2, which means go down 2, run over 1. Rise negative 2, run over 1. As you can see, if I were to connect the dots now, rise negative 2, run y. It would form a straight line. Now let's go back to the y-intercept, which is right here. Another way I could plot it is looking at this fraction. This fraction, the numerator is positive 2 and the denominator is negative 1. So I could also rise positive 2 and run negative 1. So let's see what that looks like. Let's go back to this point. Now I'm going to rise positive 2, which means go up, and run negative 1, which means go to the left. And I could do the same thing, rise positive 2, run negative 1. And as you can see, it's giving me more points that's on the exact same line. And it goes on forever. So if I were to connect the dots, and please excuse me for this sloppy line. So let's pretend I connected all the dots correctly. That would be the line, the graph of this linear equation. It's just a matter of first plotting the y-intercept and then using the slope to plot the rest of the points. So now let's look at an example where they give you the graph and they want you to find the equation. Due to the lack of me being able to draw a straight line, I did bold the points that are supposed to be on it. So let's try writing the equation for this linear line. So we know that all linear equations could be written,
and y is equal to mx plus b.
So all we have to do to write the equation of this line is figure out what is our b and what is our m. So the b is the easiest one to find out because the b is just your y-intercept. So if we look at the y-axis, it crosses the y-axis at 1, negative 1, negative 2, negative 3, negative 4, negative 5. So we know our b is going to be equal to negative 5. And to figure out our m, we just need to figure out what is the rise over run. So the first thing you have to do is identify 2 points on the graph. So let's look at this point and this point. And you could pick any 2 points you want, just make sure there's 2 points on the same graph. Now the next thing you need to do is figure out how do you get from point A to point B. Well, let's look. You could go up 2, which is rising 2, and then go over 3. So 1, 2 for your rise, and then go over 3. 1, 2, 3. So you rose 2 and you ran 3 to get there. So far it looks like our slope is 2/3. Let's see if it works with the next point. Rise 1, 2, run 3. 1, 2, 3. Rise 2, 1, 2, run 3. 1, 2, 3. So it looks like 2/3 is our slope. Now what if you chose 2 points that weren't next to each other? Let's say I didn't notice this point here and I looked at A, which is our y-intercept, and point C. Even if you looked at those 2 points instead, you'd still get the exact same slope, because in order to get from A to C, you have to rise 1, 2, 3, 4, and you would run. Keep in mind we're here right now. So you would rise 4 and you would run 1, 2, 3, 4, 5, 6. So going from A to C, you need to rise 4 and run 6. And if you notice, this fraction simplifies to 2/3. So in order to get your slope, just pick any 2 points on the graph and figure out how much you have to travel to get from point A to point B. Keep in mind, going to the left or going down counts as a negative number. So let's say I wanted to go from point A to point D. How would that give us the slope? Well, if we start at point A, we will rise -2, because now we're going down instead of up. So from point A to D, that will give us -2. And then we would have to go to the left 1, 2, 3. And because we went to the left 3 units, that counts as -3. So keep in mind, going down and to the left counts as negative. However, -2/3 is the same thing as +2/3, because negative divided by negative is positive. So again, just pick any 2 points, figure out how many points you're rising and how much you're running, and then you can create a fraction out of that number, and it will give you the slope of the graph. So the equation for this graph is going to be y is equal to our slope, which is 2/3 x, plus our y-intercept was 2/3 x, and then our y-intercept we said was -5. So I'm going to put -5, and that's going to be the equation for this graph. Thanks for watching. Hope you learned something, and I hope you have a nice day. Stay awesome.